Today we will be reviewing a test question. The review question is from Chemistry 166, and I will be helping you to understand this question. My name is Lexxis Irizarry. The question today that we will be solving is as follows. Consider a sample of methane gas in a rigid container at 100 degrees Celsius and at 1 atmosphere. If the temperature of the gas is increased by 200 degrees Celsius, what is the new pressure of the gas? So let us start by looking at the question. To begin with, let's write what exactly is methane gas. Methane gas is CH4. And as we can see in the question, we will know that we will have to manipulate the formula. Pressure times volume equals moles times their constant R times temperature. Now, let us begin to solve this question. Let's start by writing down the formula. PV equals nRT. Now, let's just start with the basics of this formula. Pressure is always going to be used and solved in ATM. Volume is always going to be used in liters. N is always going to be moles, and R is going to be always 0.082 because that is our constant. Temperature is always going to be measured in Kelvin degrees. Now let's look at our question. Consider a sample of methane gas, which we have said was CH4, in a rigid container at 100 degrees Celsius. Now, as we said, temperature is always measured in degrees Kelvin. So we're going to or change degrees Celsius into degrees Kelvin. And in order to do that, Celsius degrees to Kelvin degrees, we add our Celsius degrees to 273 degrees. And then we get 373 degrees Kelvin. Let's continue. At 1 ATM. ATM is pressure, and that's exactly where we want it to be, ATM, so we don't have to change anything about the pressure. Now, if the temperature of the gas is increased by 200 degrees Celsius, as we said, temperature always needs to be in Kelvin. However, if you carefully read the question, it says the gas is increased by 200 degrees Celsius. So that does not mean that the new temperature is 200 degrees Celsius, but 100 degrees Celsius plus the 200 degrees. So now we must continue. And that changes into degrees Celsius, but the thing is, remember, we want this Celsius in Kelvin. So we take that 300 and add plus 273 degrees to get 573 degrees in Kelvin. And that's going to be our new degrees in Kelvin. The next part is, what is the new pressure of the gas? So since we don't know what the pressure of this new gas is, we are going to leave it and we are going to give it the variable of x. Now let's look at our equation that we have written up here. Now, in order for us to get this new the new change, we have to divide this all by the final volume, the final final. Now, as we can see in the question, the only thing that changes is the pressure and the temperature. So everything else in this sample of methane gas stays the same. So we just have to, because remember it's always going to be 0.082. Now, we are going to write this equation in a more simpler and easier to look at for us. Over final equals our pressure. Oh, sorry. Our temperature initial over our temperature final. That's much easier for us to look at. So, without all the x's, and this is the formula that we're going to use to replace the numbers in. So, pressure initial, as they gave us, was 1 atm, correct? Then it's going to be divided by the x, because remember we gave pressure the variable x, atm, equals the new um the new temperature, which is 573 degrees Kelvin, and on top is going to be the initial temperature, 373 degrees Kelvin, and that's going to be our new formula when we have replaced all the variables with the numbers that is needed. So we get 1 atm, which is pressure initial, divided by x atm, which is our pressure final, equals our initial temperature, 373 Kelvin, divided by our final temperature, 573 degrees Kelvin. So, in basic math, we just cross multiply these two, and I'm going to write it here, 573 degrees Kelvin times 1 atm equals x atm times 373 degrees Kelvin. Now let's evaluate. 373 times 1 is, 573 times 1 is 573 equals 373x. So now we need to isolate x. In order to do so, we are going to divide 373x just by 373, and we're going to take 573 and divide it by 373. And when you take out the calculator and divide 573 divided by 373, you get 1.536 equals x, because we have canceled it out. And now we have found what is x. So for our answer, we have got x equals 1.536. And remember, x was our pressure. So 1.536 atm is the new pressure. Thank you for watching Chem with Lexxis. I hope that my video was very helpful. Thank you.